Alright, so today we're going to be simplifying algebraic fractions. Now hopefully you're okay with simplifying fractions or adding fractions, multiplying fractions, dividing, subtracting, doing all that without the complexity of algebra in there. Because unless you're really grounded in that, you may find this difficult. So if you need something like that, reach out and I will try and make a video and maybe I'll link that somewhere else. But the principles are exactly the same. So if we're going to add two terms, then the denominators have to be the same. Whether there's a pronumeral involved or not, we need to get to a situation where they are exactly the same. If we're going to multiply and divide, the same rules apply. Okay, multiply across the top, multiply across the bottom, and then divide is a little bit different, and I'll get to the way that I do that with you in a minute. So the first thing we're going to do, yes, I just said the same rules apply when we add, subtract, multiply, divide fractions with pronumerals. All right. So the first one, I like to start with multiplying because I know a lot of teachers will teach you adding and subtracting first, but there's a part of multiplying in adding and subtracting. So we kind of need to know how to do that first. By changing the denominator and the numerator, what you're doing is multiplying. So I'm going to do multiplication first. The first one here that I look at the denominators and don't need to be the same. Okay, I'm multiplying, so I just simply multiply across the top and multiply across the bottom. So I've got 2x times 4, and that will give me 8x. All right. Along the bottom, I've got 3 and a 5, so that will give me 15x, and I'm finished. Okay. Nothing more to do here. Across the top, I've got the 3, so I multiply, and what I like to do is I multiply the numbers first. Okay. I've got a 3 and a 4, so therefore I've got a 12. I've got an x and an a. Can I join any of those two up? Not really, anything other than ax. All right. On the bottom, I've got a 7 and a 5, so I've got 35. Okay, and I look at that and say, is there anything common between? Are there any common factors between the top and the bottom? There are none that I know of. Okay. This next one, I've got a 3x and I've got a 12. So if I multiply across the top, I'm going to get 36x on the top, and I'm going to get 10 on the bottom. And now I think about, are there anything common between a 36x and a 10? Think about the numbers first. Anything common between a 10 and a 36, and I work out that there is, and it's 2. So I say, how many 2's are in 36? And I've got 18. How many 2's are in 10? And I've got 5. All right, so then I'm just going to simplify that down to 18x on 5. All right, is there a better way to do it? Absolutely. So I'm just going to do this one again, and before I multiply across the top and the bottom, I look for common factors anywhere, and I could be across here as well between the 10, between the 12 and the 2, or the 3 and the 2 and the 3 and the 5. I look everywhere, but it has to be one on the top and one on the bottom. Doesn't matter where it is in which fraction, as long as there's one from the top and one from the bottom. Okay, so I can notice here that I've got something common between the 2 and the 12, so which is 2, and I say how many 2's are in 2, and I say 1. I think it's important, especially until you're really good at these, to put the 1 there. Okay, so I'm going to put the 1 there, and how many 2's are in 12? I've got 6. So now there's nothing else common there. I go 3x times 6 is going to get me 18x, and then I've got a 1 times 5, and it's going to get me 5. And again, I got to the same result. It doesn't matter which one of these versions you do. This one or this one, you're going to get to the same one, but you just added that step in at the end. Okay, so that's multiplication. I'm doing these relatively quickly because should be revision from the last few years. So I like to do a thing called KFC when it comes to division, just because most people know the restaurant and it's easy and it kind of works. So I say keep, flip, change. Whenever I see division, I just think of KFC, all right? That's probably why I'm as big as I am. So, the first one I'm going to talk about is I keep that first term, okay? I'm going to flip that second term, and I'm going to change that operator. I'm going to change that operator into a multiplication, okay? And then I'm going to rewrite it out, and I'm going to say 2x on 3, I keep that one. I'm going to flip the other one, so now I've got a 5 on 7, and I'm going to change that operator to a multiplication. Okay, and now I've done multiplication already. It's the easiest one of all of them to do. Just multiply across the top, multiply the bottom. So I've got 2x times 5 to give me 10x. I've got a 3, I've got a 7 to give me 21. And I've finished. Alright, the next one. I'm going to keep the first one, 3x on 4a. I'm going to change it and I'm going to flip it, and I'm saying that around the other way now, but I'm going to keep the first one, flip the second one, and change it to a multiplication. Alright, multiply across the top, and here I could look for common factors early. I could have multiplied across the top to get 15x and then to get 12xa, but I'm going to notice at this point that there's some common factors between the top and the bottom. And this one's easy. I've got a 3 there, and I've also got an x, so I can get rid of those x's as well, make it even easier for myself. Now I've just got that 1 that I forgot to write up there at the top, and I've just got a 5 there, and on the bottom I've got 4a. So I've finished. Okay, that made that so much easier that I didn't have to find those common factors later on. All right, the next one I'm going to keep the first term, I'm going to flip the second term, and I'm going to change the operator. I'm going to multiply across the top. If I've got 8 and a 3, I'm going to do those numbers first, so that's going to give me 24. I've got an x times an x. Hopefully you realise that's going to get me rounded up to an x squared, and I'm going to be over 5, and then I'm finished. All right. I look for common factors between the top and the bottom, and I can't see any there. So now moving on to the adding and subtracting. And all of them, this is probably the most challenging one because you have to think about it, you have to do something a little bit different. You've got to make sure those denominators are the same, okay? So I notice the 2 and the 4 are not the same, so I know I have to do something about that. I have to change that 2 to get it into a 4, okay? Or there may be not one number, you have to find another multiple that's common to both of them. All right, so I noticed that that's going to be common. So how do I get that? How do I get that up to a 4? I'm going to have to multiply by 2, and that means I'm going to have to multiply the top by 2 as well. All right, so then I'm going to end up with 6x on 4 plus x on 4. Now I've got my common denominators. I know my denominator is going to be 4. I think about that. I don't even have to think about that anymore. Okay, I've got 3x plus x. Now they are like terms, like what we discussed last time, and I've got 7x on 4, and I'm finished. Okay? I look for anything common between the top and bottom. As soon as I finish with a fraction, I look for common terms between the top and the bottom. Okay? The next one, I look for common multiples between 5 and 3, and there's anything before multiplying them together. So that's all. There's always a common multiple of two numbers. That is those two numbers multiplied together. Okay? It just means if there is one before that, then you might have to simplify it later on. So I've got 3 on 3 there, and I'm going to multiply the top by 5. Whoops. That's not good. Times 5. So I've got 3 times 2x squared will get me 6x squared over my 15. I've got x times 5, which is going to get me to 5x over 15. So I'm going to put that over 15. I've got my 6x squared plus 5x. Can I simplify that at any stage now? There's nothing common between the top and the bottom, so I just have to finish there. If I wanted to, probably the only thing I could simplify that to, would be I could take out a common factor there and say x outside of 6x plus 5, all on 15, which we'll get to later on in another couple of lessons. But that's certainly not necessary at the moment. All right, so the next one I'm going to look at is this one. I've got 3a over 2, so I'm looking for common denominator here, and then I can see that it's going to be 10. So I'm going to multiply this one by 5, and this one by 5, this by 2, and this by 2. What's going on here? it's going to give me 5. 5 on 10. Yep. Okay, so the next one I'm going to look at is subtraction one. I can see there that my denominators are not the same, so I'm going to have to do some work. I'm looking for a lowest common denominator lowest common multiple between 3 and a 5. And after a bit of thinking, and even if you need to write that down on the side of the page, we work out that that's going to be 10. So I need to multiply this one by 5 and this one by 2. Okay. Just a note on this, I really don't like when students, we work out that they need to multiply that one by 5, I don't want to see this. I don't want to see just 5 times that, because that's not right. You're changing, and this is an expression. It's not an equation, even though we've got some equal signs. We're saying this is equal to this. We're not creating an equation. We're looking at an expression. By writing that there, you're changing the size of that. So the only way to do that is by multiplying it by 5 on 5. Because if we multiply any number by 1, which is what 5 on 5 is, then no mathematical laws are broken, okay? So it's really important that you multiply top and bottom by the 5, okay? So then I multiply that and I get 15a on my 10, and I'm subtracting 20a on 10. I've got my common denominator of 10. I've got 15a minus 20a. They're like terms, they've both got an a term and nothing else, so now I look at the numbers. 15 minus 20 is going to get me to minus 5a on 10, and then I look for common factors between the two, and I notice that the 5 is, so I can cancel that out. How many 5s are in 5? There is 1, so it's negative a, all on 2, okay? I'm going to talk about a different way. I could have done this at some point. I could have noticed that the 10 and the 5 had a common factor. So back up here, I could have noticed that the 10 and the 5 had a common factor. Okay? So I am going to rewrite that so that it might be a little bit easier for me. So I've got 3a on 2 minus 2a on 1. I still don't have a common factor, but dealing with 1s and 2s, they're a lot easier than 5s and 10s, okay? The smaller the numbers, the easier they are. So I kind of like to reduce them down as much as I can. So I need to look for my common factor between 2 and 1, and after a bit I work out that it's going to be 2, so I can multiply that side by 2. So it's only changing one of the fractions now. So I've got my 3a on 2 minus 4a on 2. Oops, did that get deleted over there? If I've got 3 a's, they're the like terms. I will actually write this one in here. They're like terms, so I can join them up. If I've got 3 apples, I take 4 away. I've got negative 1 apple on 2. All right? All right. So the main change to the normal fractions work is when the denominator is a pronumeral. Okay? So I need to do some work on this one. So I've got this time I'm looking for a common denominator between 3x and 3. Okay, I need to multiply one of those two terms to get them to be exactly the same. And this is a little bit harder. You hopefully would have done some work finding common factors between things in previous years. If not, again, I'll reach out and I'll try and make up some videos for you. But the common thing that I'm going to have to multiply this time by is this term I'm going to multiply by x, because if I multiply 3 by an x, that's going to get me to 3x, okay? So that's going to be my common denominator there. I've got 2 over 3x, and I've got 4x there over 3x. Now I've got my common denominator, so I can just write it on the bottom. At the top, I've got 2 plus 4x. Is there anything common between those two? No, so I can't join them up, and I'm finished, okay? Another one here, what do I need to multiply x squared by? What's common? And I'll quickly do a little bit of a spiel here. I've got, yeah, no, that's okay. I might just stick with that. So what do I need to multiply? Which is the bigger one? That's the one way I think of it. Which is the bigger one? And I look at that and I say the x squared is. So I'm going to have to do something to the x. Is there anything I can multiply the x by to get it to the x squared? And hopefully you can see that it's going to be multiplying by x. So I'm going to be ended up with 3 on my x squared. And then I've got 2xy on my x squared. And once I know they're the same now, they're all both on x squared, and I've got 3 plus 2xy. Are any of those like terms? So I look at this term and this term. Are they like terms? They're not, so I'm finished. Okay?